Hey everyone, my name is Leon. I'm the manager of data engineering at FlockSafety, and today I'm going to talk about real-time analytics powered by ClickHouse. So, what does FlockSafety do? Um, we have this kind of three-tiered approach, and it's just a catchy term. Detect, decode, and deliver. So, detect, we have a suite of evidence capture devices in the field. There's some listed there. Falcon, which does automated license plate reading, captures images. Raven captures audio and classifies audio sounds as gunshots, tire screeching, glass breaking. We have Condor, which is a live video product, and then we have Wing, which is a compute framework that can power many of these devices. We decode that data with machine learning. So we do vehicle fingerprinting, which is what we call it, which is classifying a vehicle based on certain attributes that we can then search on in our delivery layer, which offers search, a mobile app, real-time alerts, and now what we'll talk about, analytics. So what is traffic analytics? This unlocks a lot of potential for customers to look at insights based on the images that their cameras are capturing. So as you can see on the right there, we have some graphs, which is a sample image from our traffic analytics portal. And this data is aggregated at 15-minute intervals across all of your devices at 3 different cardinality levels. We'll talk about that more in a bit. So this was our architecture before trying out ClickHouse. We use Amazon Redshift as an enterprise data warehouse. So we have a provision Redshift cluster, and then we use Redshift data sharing to create an embedded analytics Redshift serverless instance. And then to build these analytics models, we used dbt, which was orchestrated by Prefect. This transformation layer would run once a day due to both the volume of the data and also the architecture we were using to surface that data to our customers. We were using a tool called Amazon QuickSight to build the dashboards and then embed into our front-end UI. And we were using a system called Spice, which is offered by Amazon QuickSight, which is basically just an in-memory DB to sort of speed up the queries to your backend. So what did that mean for the performance of this product? One, the thing I mentioned was a daily refresh cadence. So the data was only updated once per day. So the customers would get no intraday context into their data, and they'd be looking at yesterday's data and before, which for a law enforcement customer, that may not be as important to them as maybe a commercial customer or a private sector customer. Long refresh times. So this was probably the biggest issue with this architecture. So with an in-memory database, you need to sync the data into it in order for Amazon QuickSight to be able to query that in-memory database. So those 6 squares there come from a monitoring dashboard that we built to basically look at what the Spice data look like on a daily basis. So in the vehicle type instance, which is all the way on the far right, the sync into Spice took 4 hours. So that means that there's no data available to customers for 4 hours. This obviously hurts their ability to get insights from their data. Luckily, we did this overnight, so nobody was really looking at it. But that type of downtime is really not going to be tolerated, especially for law enforcement customers. So the other issue with Spice is they have hard constraints on the size of these data sets that the dashboards can use. So their constraints are either the data size or the amount of rows in a data set. So the size constraint was 1 terabyte, and then the row limit was 1 billion rows. So all these data sets, as you can see, the one on the right had 957 million rows, and the asterisk there says that was truncated to 30 days worth of data because the rest of the data could not fit into that Spice data set. So we were not even delivering the full scope of the client data while using this in-memory database. So another concept that's very important is row-level security. So Amazon QuickSight supports row-level security natively, but there's a constraint of only 256 unique keys to be sent with each query. So on the right side of the screen, you can see an example of what row-level security would look like in the classic sense. So if you look at the green organization 22, it will have access to those green rows in the table. And then organization 819, the blue one, would have access to the blue rows. An important concept of Flock is data sharing and camera sharing. So as you can see in the bottom diagram, organization 99, the orange one, they're able to share their cameras with organization 22, and they should be, and then organization 22 would be able to see all the data that's in orange and green. This is obviously a toy example. We have tens of thousands of cameras live in the field. So we were not able to support full camera sharing due to the fact that we could only pass 256 unique keys with each embed request to Amazon QuickSight. So to recap, the key issues were the limited retention due to the Spice dataset size, the downtime associated with dataset refreshes, the 256 key limit for row level security, and then obviously the daily refresh cadence. So what did we try? Like I explained, we were on Redshift with Prefect and DBT, syncing into Spice. We tried an approach to use direct query on top of Redshift, but the concurrency limits on Redshift made this not a scalable approach. We then tried syncing the data from Redshift into an Aurora Postgres instance to see if we could get better concurrency. But we will go over the results in the next slide. But we also tried an S3 and Trino approach with the same idea of syncing data into S3, using some funky partitioning to sort of make the data more accessible and then support much more concurrency with a self-hosted instance of Trino. And then, of course, we thought about using ClickHouse with aggregating merge tree and materialized views. So that would give us real-time data with direct query to ClickHouse rather than using Spice. So what are the results? Redshift, as we talked about, the refreshes make the data unavailable, the camera sharing is not supported, and the reporting is not real-time. Aurora, this was not even able to return data to the caller within the timeout specified by Amazon QuickSight. The same goes for S3 and Trino. So these three options were definitely not viable for the SLA we want to provide our customers. So enter ClickHouse. This is what we're here to talk about today. So this is kind of an architecture diagram in a bridged version to explain the data ingestion. So like I mentioned, we have devices in the field capturing images. Those images get sent up to the cloud. ML inference is run on them. And then that data is then sent to SNS, which supports our regular software pipeline as well as analytics. For our ingestion, we use Kinesis Data Firehose to process data from SNS. And then we put all of that data into S3. So that supports both Redshift as well as ClickHouse. We also have a lot of Postgres databases at Flock. We use Debezium to do change data capture replication, push all of that data to Kinesis Firehose as well, and into S3. And then to ingest to ClickHouse, we used ClickPipes, which have been extremely performant, very low latency, and we haven't seen any issues with those. But what this translates to is over 1 billion ML predictions per day, and a peak data size ingested of over 20 megabytes per second at peak. And we've had zero downtime with ingestion, and this architecture has been very scalable to get data into ClickHouse. So now we'll talk about what is the architecture of surfacing these reports into Amazon QuickSight. So like I mentioned, we use ClickPipes, and then we have our ML prediction table. And then we use three different aggregating merge tree destination tables for the vehicle type, the vehicle make, and then the license plate state classifications. And we use a materialized view using unique state and unique merge to, at insert time, aggregate data into the aggregating merge tree table. So there's no need for DBT or prefect to orchestrate any of these transformations. They are at insert time put into the aggregating merge tree table. And then when the caller comes to look at the reporting tables, they use the unique merge paradigm in the aggregating merge tree tables, and then join up other dimensional tables that use replacing merge tree from Debezium to enrich that data with all the contextual information about a camera or about an organization or a network. So what does this mean for our end users? They now have real-time analytics for their camera traffic, and there's no more constraints on size or on row level security without having to use the RLS keys. So all of the sharing data is enriched from these dimensional tables, and then at query time, based on information about our user from Auth0, we're able to give them the result set that they should get based on their permission level. So what are the results? Zero downtime for getting new data. Full scope of intraday data is available due to the streaming ingestion as well as ClickPipes being very low latency. Query time of under 5 seconds for some of our bigger customers. We're still working on optimizing that. Shout out to Jake, Larry, and Shri from ClickHouse. They've been super helpful on helping us optimize. And then, of course, the extended retention is something this has been unlocked due to ClickHouse's scalable architecture. So final thoughts. This is kind of a recap. Real-time analytics, camera sharing support, extended retention, and zero downtime is what ClickHouse has unlocked for this analytics embedded analytics product offering. And then the next steps are continue moving these analytics use cases to ClickHouse, specifically around investigation support. Thank you.
You said your arch now is 1 billion events per day.
Yeah, it's over that now, but it's roughly about 1 billion ML predictions per day.
So where do you think you'll hit the next bottleneck? Either in terms of events or in your architecture diagram, what part will fail? Will keel over first?
I think we need to do a good job of partitioning for the aggregating merge tree reporting tables. The cardinality can get pretty high. Like I said, there's tens of thousands of cameras. The time intervals are 15 minutes. So there's 96 15-minute intervals every day. And we intend to keep this data, quote unquote, forever. And then if you think about what the dimension of that is, license plate state, for example, there's 50 states. A camera in New York, for example, probably won't see all 50. Well, maybe New York's not a good example. A camera in New Jersey will probably not see all 50 states within a 15-minute period, but you could sort of extrapolate what that cardinality is. So the challenge will probably be scaling these aggregating merge tree tables, partitioning them properly, having the right data skipping indexes, and just keeping up with the growth that we're expecting.
Hi, just a quick question. So for the how's the experience migration from the AWS Redshift to ClickHouse? You have a lot of integration there as well as the pipeline.
Yeah, so I'll go back to the ingestion. So actually, a lot of this ingestion is sort of reused. Up to the point of S3, this is sort of the same way that we do ingestion for Redshift. So having that object storage layer right before we ingest, that makes a lot of our ingestion pretty portable. It does depend on what sort of compression techniques or what sort of file types we store in S3. But ClickHouse was able to support like gzip JSON the way we did it for Redshift. So a lot of it was like, okay, start loading from this S3 bucket. So it wasn't really hard to move the ingestion over to ClickHouse. I think part of the challenge was sort of getting ramped up on the table architectures, like replacing merge tree, aggregating merge tree. But again, we got a lot of help from the ClickHouse cloud guys that we work with.
So I'm curious, like for the row level security, are you using a customer KMS key to equip that, or yeah? And how
It's pretty much based on their organization plus a role. And then those RLS keys are sent with an embed request from Amazon QuickSight. So we don't have to use KMS. It's sort of managed by Amazon QuickSight via the embedding and then whatever parameters it sends through in the request.
And then ClickHouse is natively supporting that, right? The transitions, or do you have to do any like a custom script to supporting the QuickSight integration with the RLS ClickHouse?
No, it's part of the connector that Amazon QuickSight supports.
One last thing is how much is the cost estimation for that? Like, is that going to increase from using the new architecture, or yeah, just kind of curious.
Unfortunately, I can't really comment on that. But I mean, with ClickHouse, it's usage based, so you know you sort of get some cost arbitrage there. If you have downtime, you have your cluster can idle. But I can't really answer that. I'm sorry.
I have a question. So I see this slide where you start with images all the way on, here. And then what type of data gets to ClickHouse actually?
So it'll be all the ML predictions from our models, basically. Vehicle type, vehicle make, the license plate number, vehicle color. It's all the vehicle fingerprint stuff, as well as other contextual information about the camera that it came from.
Any other questions? Nope. Cool. All right, I think that's it for tonight. Big round of applause for all of our speakers.